Yeah, we'll do it here. If you will remember, we had solved one problem with 9 transactions, I1, I2, I5, I2, I4, those. The same problem, we will do it by using FP growth algorithm. And we should, anyway, as it is, as we are finding the frequent item sets, whether you do it by using a priori or FP growth, the item set should be same. We'll compare and find out whether both are giving the same answer. But the approach will be different. Both are used to find the frequent item sets. You remember, isn't it? I1, I2, I2, I1, I5, and I2, I1, I3 were the three frequent set items which we had got when we had solved the problem by using a priori algorithm. I'll write down that. So we are discussing FP growth, that is frequent pattern growth algorithm, to generate the frequent item sets. Okay. So we have the transactions. So it's they have just taken as 100, like in that way. We'll just take it as T1, T2, T3, T4, T5, and we have the list of items. The same problem what we had solved by using a priori. So if I write down, you'll remember. We had done this, isn't it? I2, I4, I2, I3, I1, I2, I3, I1, I3, and we had I2, I3, I1, I3, I1, I2, I3, I5, I1, I2, and I3. So these were the list of items. Okay, what we had, it's the same problem what we had solved by using a priori. Let's do it by using FP growth algorithm, by constructing a FP growth tree. Okay, so first thing whatever we'll do here is we'll just try to find the, okay, here only, here I'll write down. We'll try to find the item set. We'll write down item set and the support counter. For this problem, we have the minimum support count equal to 2. Okay. So we have the support count and the item set. So items we have are I1, I2, I3, I4, and I5. We have these items. Let's count and find out what's the count of I1. Yeah, I1, 1, 2, 3, 4, 5, 6, right? I1 is present in 6 transactions. 1, 2, 3, 4, 5, 6. Yeah. I2, 1, 2, 3, 4, 5, 6, 7. Yeah. I3, someone should count and tell me. Immediately I'll write down. Yes, I3, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6. Let me check whether I have just I1, I2, I3, I1, I3, I2, I3. One second, is it the same? I've just I2, I4, I2, I3. Oh, this is I4. That's why. This is I4. So it is I1, I2, I4 it is. Okay. Then I1, I3, I2, I3, I1, I3. Okay. Okay, count now. I3, we have 1, 2, 3, 4, 5, 6. I4, Excuse me. I4 we have 1, 2, I5 1, 2. So we have 2. Okay, this is the support count. All can be moved on to the next stage. That is because the support count is 2 and all are having minimum support count of 2. Right? Now, the next thing what you have to do in FP growth algorithm is we have to arrange these items in the descending order of their support count. The first thing what we do here is we have to just arrange these items in the decreasing order of their support count. So if we do that, item set and the support count, which one comes first? I2 and the support count is 7. Then comes I1, support count is 6. Then is I3 with support count 2. Then I4, I5. Okay. So what's the next step we have done? The first step is that we have just calculated the support count and then we have just arranged these items in decreasing order of support count. Okay, we have just arranged it in decreasing order of support count. Then we will construct the FP tree now. Now we'll construct FP tree. So how to construct FP tree? We'll just look in. Okay. Yes. We'll construct the tree here. Yeah. First, in each transaction, we will arrange the items in their decreasing order of the support count. You know the support count here. In this transaction, it's in different order. Now we will just arrange them in the decreasing order of their support count. So which comes first here? According to the support count, which one is the first? Yes, you all are listening to whatever I am explaining. Yeah, look into the support count here and you have to just tell me which one comes first. So it is 2, 2. 2, 2. I for I5 is 2, 2. Yeah, you tell me now. Which one is first? These I am rearranging them according to the decreasing order of their support count. Which one first here?
I2.
Yes, I2 and then
I1.
I1 and then
I5.
I5. Likewise, you arrange everything. We'll arrange and keep it so that we will construct the tree or else one by one we can construct by taking one by one. Okay, let's start with the null node. Okay, this is our null node. Then, which is the first item? So first item is I2 and it is occurring for the first time. So we'll note down the count, how many times it is occurring. So first it is occurring for the first time. So I have I2 and then I will just, what's the next item? I1 with count of 1 and then I5. Okay, so then I have I5 with a support count of 1. So I2, I1, I5. Next transaction, if we take, it's already in order, isn't it? I2 first and then I4. It's already in order. So I2 and I4. I have to represent here. Now I'll come here. I2 is already present. So I'll increment the count to 2 here. So I'm incrementing the count to 2. And then I just search whether I4 is already present so that I can increment the count there itself. As it is not present, I'll just take a different path and I will note down the transaction I4, item I4, and it is appearing for the first time. Okay, is that clear? Okay, now I2, I3 already in order. I2, I3. So how do I move now? I'll come to I2. I'll check whether I3 is there. If it is there, I'll just increment the count. if it was present, it should have been either here or here. It's not present. So what do I do here? I will just add it. I3 count is 1. I2 has become 3 now. Okay. I2 is 3 and I3 1. Next, do I need to arrange this items which are there in the transaction, or they are in order already?
I2 should come first.
Yes, I2 I'll have, and then I'll have I1, I2, I1, and then I4. Okay, I've arranged it. Now I'll just check here. I2, yes. I1, yes. I1 also I have. I4, no. So I'll just write down I4 here. So I2 count I'm incrementing by 1. I1 count I'm incrementing by 1 more. And then I4 first time. In this pattern. Already it is there. I2, I4 is there. But I2, I1, I1, this is the first time. Okay. Now, likewise, we arrange everything. So let's move on now. I1, I3 already in order. So I1, just check here. The from root we are branching with I2. We don't have I1. So what do? We branch it to the right. Okay. So I1, the count 1, and then we have I3 over here with the count 1. Okay. This is left subtree. This is right subtree. This is your FP tree. Frequent pattern tree. Okay. Now I2, I3 in order. Isn't it? If you look here, I2, I3 already in order. Just check. Let's check. I2 increment. Now I3, yes, we have here already. So I'll just increment this to 2. Okay, I2, I3 over now. I1, I3 in order. I1, I3 again. I1, I3. Let's see here. Yes, I1 and I3. Okay, then here this one. We'll arrange it. I2 first, then I1, and then I3, and then I4 according to the decreasing order of their support count. So let's check now. So I2 will increment again. We got 6. Okay, then I1 we have. Yes, we'll just increment. Then after that I4, I5 we have, but we need I3. So we'll just write one more. I3 first one and then I5. I5 1. Okay. So yes, fine. Now we have this. Let's arrange it as it is not in order. I2, I1, and then I3. I2, I1, I3. Let's check now again. So we have this 7. Okay. Then I1, 4. Then I3. Yes, I can take this root and I have I2 here. I can increment. Okay. Fine. So we have completed with all the we are representing all the items in the form of FP tree with their counts. Right? Let's cross verify whether it is matching with this. I2 7, I1 4, then here plus 2 6, right? So I1 also is appearing 6 times. The support count is 6. Then we have I3. Yes, I3 we have 2, 4 and 6, right? I4 we have it here and here, so count is 2, and I5 again we have here and here, count is 2. So we have got all the support count properly. So FP tree is represented properly. Is it clear till here? It's not that tough. Easy only, isn't it? Okay. Fine with the present representation of FP tree. Hope you don't have any doubts with this. It's quite easy. Okay, now we have to write a table and identify the frequent patterns which are being generated. Using this FP tree, we'll do it. Okay. Yes, we'll start writing the table. Item. Okay. And we have the conditional pattern base. And then we have the conditional FP tree. And then the frequent item patterns which are generated. Fine. Okay. We should always take the item with the always take the item with low support count. Okay. So we'll start with I5. Item I5 will start. Okay. Now, yeah, to get I5, the patterns which are used. See, to reach I5, the path we are taking, we'll just check here. So I'm taking the items in the descending, increasing order of their support count. So I've taken I5 first. Now I'll check where it is in the tree, I5. So I2, I have to pass through I2, I1, and then I'll get I5. So to reach I5, I should take the path I1 and I2 pattern. The pattern is I1, I2, and I can reach I5. What is the support count of I5 here? 1. That I'm noting down here. Support count of I5. Okay. Fine. Clear?
Yes, ma'am.
Yeah. To reach I5, I1, I2, I1, and then I reached I5, and the support count of that I'll record and the path I've taken. So it is I2, I1. Sorry, I2, and then I1. Fine. Next, where else can I find I5? I have this path again, isn't it? Here. So I2, I1, I3, and the support count is 1. So we have I2, I1, I3 with the count of 1. Okay. This is the conditional pattern to reach I5. So I2, I1, I5, I2, I1, I3, and support count of I5 I am recording here. Fine. After that, we will just have this, we will This means that the count for I2 is also 1, I1 is also 1. I2 1, I1 1, I3 1. I'll sum up here. For I2, what is the count? According to this, I2 is present in both the transactions. So count 1 plus 1, it is 2. And I have I1 also present here. So what is the count? I1, in both the transaction it is present. It is 2. And I3. I3 is present in only one transaction and the support count is only 1. Whereas the minimum support count for this for this algorithm or for this problem is 2. So we will not consider that. You got it? You got this point? I have just counted the number of times the item is present in each transaction. So I2 is present. So this means the count for both is 1 1. Count for all three is 1 1 respectively. So I2 1. I2 is present in both. So count is 2. I1 is present in both. Count is 2. I3 is present in only this and the count is 1, which is less than the minimum support count. Hence I'll write it. I write only for I2 and I1. Okay. Now the frequent pattern, what will be generated? It's nothing. It's very simple. The frequent pattern which will be generated from this, we'll just combine this with item. So we will have I2, I5. So what are the combinations we can have? We can have I2, I5. Count we'll take down 2. Then I1, I5. Okay. I1, I5. Count is 2. And we can also have the combination I1, I2, I5. So I1, so I2, I1 together. I'm performing join operation. That's it. Sorry. So it is I2, I1, I5, count 2. Okay, this is the frequent pattern generated with I5. Got this one? So to reach I5 and the support count of I5 here, then we will count in how many, if it is appearing in both the transaction, count is 2 because this one is for both. I2 one time, I1 one time, I2 once, I1 once, I3 once. So we'll take the sum and I3 we are not considering here. That's because the support count is less than 2. Then we will join this I2 with I5, I1 with I5, and then I2, I1 with I5. The count we have written. Likewise, we'll do it for all the items.
Ma'am,
Yeah.
for I2, I1, I5, how is the count 2? Because for the second pattern we generated, it goes through I3, no, ma'am.
Which one? But as its support count is 1, we are not considering this.
So even if it's not there, we should consider the count as 2 for the frequency pattern generated.
Yes, because here the count of these we are taking.
Understood.
Okay. Yeah. So I2, I1 with I5 and the count is 2 here. So here we'll take the minimum count actually. If we had 4 here, we would have taken only 2. The minimum count is what we will consider here for this frequent pattern generated. Okay.
Got it.
Yeah. Next, for I4, yes. To reach I4, let's check here. Yeah, you check here I2, isn't it? I2, I1. Let's move first in this way. I2, I1, and here we have I4. So I2, I1, I4, 1, isn't it? I2, I1, and we'll get I4, and the count is 1. Next. Then we have I2, and the count is 1, I4. Okay. I2, by coming to I2, we can go to I4, and the support count here is 1. I'm writing it 1. Okay. Now, here, conditional FP. Yes, if we will see here, I2 is present in both the transactions. So I'll add this count. I'll add this count. I2 is twice. And what about I1? I1 is present in only one, and the count is 1. So it is less than the minimum support count. Hence, I'll not include that here. Right? So we have only 1 here. So for this, if I generate the frequent pattern for this, so what do I get? I will get I2 with this. I'll join I2, I4. I2, I4, 2. That's it. Isn't it? Only one we got because we had only one conditional FP tree here. So we perform join operation with this item. So I2, I4 with 2. Next. Yeah, let's check here for I3. So this I3. Yeah. So we had, so I2, I2. Oh yeah, here we have I3. So we can take I2, I1, I3, and the count is 2. Isn't it? So we'll take I2, I1, count 2. Yes, we'll take it. I2, I1, count being 2. This I2, I1, I3 we reached, and its count is 2. And whereas I3 is present, we have it here as well. So I2, count 2. So we have I2 and the count is 2 here. And it's also present in the right subtree. Okay, this is left subtree, and the transaction is also present in the right subtree. So we'll consider that I1 and count is 2 here. I1 with count 2. Okay. So we have these conditional pattern base. Now let's combine now. So we have I2 twice here, 2. So 2 plus 2, 4. I2, 4. And then I1. I1 is present only in this. This is left subtree and this is right subtree. So we'll take it separately. So I1 here twice. Okay. And in the right subtree we have I1, which is twice. Okay. Yes. Now let's perform the join operation. Yes. I2 with I3. I2 with I3. I2 with I3 join, and the count here 4. Then I1 with I3. Okay, I1 and I1 with I3. Yes, I1, I3, 2, and I1, I3, 2, and here again I1 I3, 2, isn't it? We have two transactions, one in the left side and one in the right side. So 2, I1, I3 again, and it is 2. So we'll add that and make this 4. Count as 4. I1, I2. It's there in left subtree as well as in the right subtree. So we'll combine that I1, I3 and increment the count to 4. Is that clear? Then we can have I1, I2, I3 combination. So we will have I2, I1, I2, I1, I3 combination, and here we will have to take the minimum. Okay. Here we have I1, I2, I3 which we are taking. So in this we have 4 and 2. Here we'll choose the minimum value. So we have this minimum count taken as 2. Okay, so I2, I1, I3 is 2 here. Got it?
Yes, ma'am.
Yes. Next one you can just try. So which is the next item we should consider? I1. Can you just continue and tell me? Or else we'll do it. Which are the next items we have? For I1, I'll just move it. Let's check. You're checking for I1. Is it clear till here for everyone? Because only one is responding. Only Milan is responding. What about others? Others are listening or just?
Yes, ma'am.
Yeah.
Listening, ma'am.
Okay. Yes. For this I1, yes, we have I2 and here the count is 4 for I1. So we have I2 and the count is 4, isn't it? So here right side immediately will not consider that. So we will have I2 4 because we need to find out frequent item set. So we will just find out how we can reach I1 through I2 with the support count 4. Then we will have I2 join operation. I2, I1, 4. I2, I1 and it is 4. Okay, I2 is considered as a root node and will not perform for it. See, if you will just look into this, if you will remember the program, see 3 items at generation, if you will just check, see here, I2, I1, I5 and I2, I1, I3. You remember, you can take out, if you will just compare it with your, which one? A priori algorithm, if you will remember, we had got this I2, I1, I5 with support count of 2 and I2, I1, I3 with support count of 2, isn't it? So these are the frequent patterns which are generated. 2 items also we have and 3 items also we have. For I2, one second. So for this I2, as we don't have any in between patterns, we'll just not consider this, isn't it? So we have this. Can you just check with the a priori program and check whether it's the same? It will be the same, isn't it? So we will see. We had this I2. Yes, we had this I2, I1, I5 with 2 and I1, I2, I3 with 2, if you will remember this underline. And when we considered the two item set generation, we had, you take that and just compare it with the whatever we have got here. See, for two item set generation, we had I1, I2, 4. Let's check. I1, I2 with 4. Just cross verify and check. Yes, I1, I2 we have with 4. I'm just comparing it. I have the problem here. So we add this item set I1, I2, 4. And then we had I1, I3, 3. Let's check. I1, I3 with 4. Yes, we have it here. And then we had I1, I5 with 2. Yes, we have it here. And then we had I2, I4. One second. I2, I3 with 4. I2, I3 with 4 we have here. And then we had I2, I4 with 2. And I2, I5 with 2. If we will cross verify, these are the two item sets which we have generated, and this is the three item sets whatever we have generated, underlined one. So the problem gives the same answer, but the method whatever we are following is different. So the thing is, it's easy to represent by using the FP growth algorithm. Here so we are just encoding the data using the compact data structure. This is a FP tree. This is the compact data structure. That's what they say. The representation is compact by using this data structure, FP tree data structure. Using a compact data structure, which is the FP tree. Yes. It gives the same answer, but the approach is different. Have you all understood this?
Yes, ma'am.
Take one more problem and you should solve it. Then it will be more clear for you. Fine, not that tough, isn't it? Compared to that, this is easy only. By traversing through the FP tree, we can just find out easily. Just note down. We are not doing for I2 because we don't have any intermediate. This even for I1 here, this side. Even the subject is new for me as well. So if you find any problem, you just inform me directly, okay? So that I can correct myself. You just don't take it to your directly to your higher authorities. Let's discuss first, then I'll try to correct myself or I'll try to improve myself. Then if in that case also you're not satisfied, then you can just, otherwise directly you please don't